In this video, I'm going to explain classes. Classes are available in pretty much every language, or at least most of the languages that are out there today. I'm going to use C# for this. You could certainly use any language you'd like. What I really want to focus on are three aspects of classes. I'm going to go through fields, constructors, and methods. There are other different member types of classes. I could go through properties, I could go through events, there's other operators, but I'm going to focus on those three because these are kind of the universal three across most languages that deal with object-oriented concepts. So I've got Visual Studio Code open here. Let's go and open this up and let's think through a class that we want to implement so we can talk through what classes are and how they work. So let's think for a moment that in this particular application, we need to model employees. So we're going to have employees, they're going to have information so we can deal with payroll, so we can deal with paid time off, whatever that might be, vacation time, etc. So we want to create a class that lets us deal with that. So this application is going to deal with employees and the behavior associated with those employees. So we need to create a class. Think of a class as a template or a blueprint for objects of that type. So in our case, we're going to probably have a whole bunch of employees, maybe 50, 100, 200, 500, 1,000 employees, right? We're going to have a whole bunch of different employees. So all of these different employees, they share traits in common. They share information that's in common to the system. Maybe they have social security number. Maybe they have a name, first name, last name. Maybe they have a pay amount, an amount of time off, right? So there's all sorts of different data elements and different attributes as well as behaviors that are going to be in common across these. Those attributes, the behaviors and the data elements, those become part of the class. So let's walk through this real fast. Let's create one. So I'm going to say public class, and this will be employee. And so now that I've got my employee class, I can start adding things in here. And so there are, and I mentioned this before, there are fields, constructors, and methods. And those again are going to be the three with which we're most concerned for this particular example today. So let's start with fields. Fields are basically containers for data that are going to be common across. The data isn't common, but the containers are common across the different employees. So for example, we're definitely going to want a social security number. So I could create private string social security number. Now I'm putting an underscore in here. You don't have to do that. You could just call it social security number. The underscore is a convention that a lot of developers pick up for private fields. So it lets us know A, that it's private, and B, that it's a field. That's optional. Again, you don't need that, but since we're dealing with fields, I'm going to go and add that in. So this is the social security number. So this field, this variable, is going to be duplicated for each employee that I create. So if I create Bob, he has a social security number field. If I create Alice, she has a social security number field, and so on and so forth. So this, again, this employee class is a blueprint for each employee. Each employee is going to have this social security number field available to it. The employee may also have a name. So let's do private string. Let's just do full name. I'm not going to worry about first and last. This will be full name. So this could be something like Chad Greer, where I have a space in between. So whatever their full name is. There could be other data elements. Maybe we need to know their hourly wages. So we'll say private. I'm going to use a decimal because we're dealing with currency. So I'll say hourly wage amount. So again, each employee may have a different amount that they get paid. So this is how we're using fields. Fields are available to us so that we can store information for an employee that will be pertinent later on. So now let's talk about constructors. Constructors are special methods that we use to create one of these. So the question becomes, how do we create an employee in the system? Not in the real world, but how do we create one? How do we generate one in our system? So there's lots of different ways. You'll have to talk with your business people and talk with the stakeholders to try to understand what this looks like. But for now, just suffice it to say that when we create an employee, there's probably certain information that's required. And in our case, let's assume that social security number is required. So we're going to create a constructor. And so it's just going to be public employee. So the name of the function and the return type are the same. And we're going to need a social security number. So we're saying we require social security number to create one of these employees. And then all we really need to do is hold on to that. So we'll say that equals social security number, and now we're holding on to it. Now, when we create an employee and give it a social security number, we're holding on to it in the social security number field. Now, keep in mind, we have not set full name and hourly wage in our constructors. So those would be not available. Those would be null for full name and 0 for hourly wage. So we could add an additional constructor where maybe we want to optionally specify those values. We'll say string social security number. And this is called overloading constructors, where I provide multiple constructors, which means multiple options for creating one of these. So I'll now say string full name and decimal hourly wage amount. And so here I'm just going to copy this line because we're going to do the same thing. And then we'll also hold on to full name and then hourly wage amount. I could create another constructor in between these two that would just have social security number and full name and not hourly wage. So I could do that. I could create one that takes full name and hourly wage, but not social security number. So I've got all sorts of options in terms of how many constructors and what I create. What really drives this is when we talk about the system, we ask, well, what information is required when you enter an employee into the system? So this is basically saying, well, the social security number is required. So that means it's going to be in every single constructor. And in addition to the social security number, we can optionally pass the full name and hourly wage amount if we have those. So those are our constructors. Again, these are how we create an employee in the system. So later on in the code, we might say var customer equals new customer, and we'll pass 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's our social security number. And then customer B might be a new customer, and we pass 987, 65, 4321. And then maybe this time we say Bob Peterson, and he's getting paid $12 an hour. We'll just do 12 in. So this is how we would use these two constructors in code later on outside of the class. So that's the idea behind the constructor. And then finally, methods are how we expose behavior. So what are the methods, the behaviors that we need to expose? Well, again, we need to talk with our business stakeholders. What we expose is largely going to depend on this particular application, what we're needing to do. So let's say we talk with them and decide we need to pay payroll. So we need to calculate their payroll amount. So let's create a method that's going to return a decimal, because that's the amount. And we're going to say calculate payroll, and we need to know how many hours they put in. So let's do decimal hours, because maybe there's half hours or quarter hours. So we'll do that as a decimal instead of a whole number. And now from here, what we can do is we can return this hourly wage amount times the hours. That's a pretty simple method. Now notice hourly wage amount is private. It's a field we're not exposing, but calculate payroll is using that to publicly give a payroll amount based on the number of hours. So this is the difference between having data and exposing behavior. So that's a simple method that we could do. Let's say we also need the ability to update someone's name. Maybe they have a legal name change or they get married or something along those lines. So we may want to set the full name. So let's create a method that allows us to do that. So we'll say set full name. We'll do, and I'm going to call it value. You call it full name. You could call it name. It doesn't really matter. I'm just going to call it value. And what we'll do is we'll say this underscore full name equals value. And so now we have a method that allows us to change the name of the employee. We could do the same thing with hourly wage amount. Maybe they get a raise. So we could set hourly wage amount. And again, we'll say decimal and a value, whatever that value is. This hourly wage amount equals value. And so now we're starting to expose behavior that the application may need to use as a part of the user interface or the services or whatever we're exposing here. So that's the idea. And I can go on and on with methods. I could create a whole bunch of them, but again, what I create is going to depend on the use case. So hopefully that makes sense. Let's do another example. So maybe another example will help make sense. So we'll do C#. So in this case, let's create a class. So we're going to create a new class called shed. So in this particular case, what we're doing is, let's say we work for a company that custom creates sheds for people. So this would be the shed that we're going to create for our customers. So again, I'll just create these. So what does a shed have? Well, a shed may need to have a color. So I'll do a string for now for color. It's going to need to have the dimension. So it needs to have a width and a length of the base. And then it's going to need to have a height of it. So we're going to need those dimensions. So let's say we'll create private. We could do double, we could do decimal. I'm just going to do double in this case since we're not necessarily dealing with money, and rounding errors of less than 100 are probably not terrible. So we'll say base width and private double base length. So the reason I'm putting base in there, I could just call it length and width, but if you're reading the code, how do you know the length and width of what? Is it the length and width of the shed or of the base or of the roof? Which arguably those could all be the same thing, but I'm going to make it explicit. So I'm going to say this is the base length and the base width. And then I'm going to have another double that is the height of the shed. And I could add more things. Maybe I need materials. Maybe I need number of windows. Maybe I need door type. There's all sorts of different fields that I might be able to add in here. What I add is going to depend, again, on the use case. What are the different aspects of sheds that this company is able to build and able to customize? I don't know that off the top of my head. I'd have to talk with the business to try to understand what that is. So there's our fields. Now, again, how do we create one of these? How are we going to create a constructor? What can they create, or what do they need to create it? And what can they change later? So let's assume that the color is variable. And let's also assume that the height might be variable, but the base, the length, they absolutely need to specify those. So I'm going to start with a constructor that actually has basically all of the different values. So we'll say double base length, double base width, double height, and then a string color. And all we'll do here is just hold on to those. So base length equals base length, base width equals base width, height equals height, and color equals color. So a very simple constructor, just lets us pass everything in. But I want to make it optional for the height and the color. So I'm going to add another constructor that says, in order to create this one, all I need is the base length and the base width. Now here, I could do the same thing where I just copy these lines, but I'm going to do something interesting, something a little different. I'm going to call this other constructor, and I want to pass values in default. So I'll say, call this constructor that takes base length, base width, those are those values. The height, we're going to default to 10 feet. I made that up. I'm going to assume that I talked with somebody and they said, yeah, our default height is 10 feet. Great. And our default color is gray. So now I've got a constructor that calls this other constructor, which is this one, and passes in the length and the width, but it hard codes 10 and gray as the height and the color. So now I've got two constructors, one that takes just base length and base width, and another that takes all of them. And so now again, I have the options for calling the two constructors. And I could add more constructors, I could add more parameters, I could add fewer parameters, again, however you need to do it. But again, those are the different ways that we might want to create one of these shed objects for a customer. And then finally, we need to have methods. So what are our methods? Well, maybe as a part of this, we need to calculate the area. So let's say double get area, or calculate. I'm going to say calculate area. So calculate area, it's not actually going to take anything because we don't need to know anything. What we'll do is we'll simply say return this base length times this base height, base width rather, times this height. So very simple formula. There's the area, the internal area of the shed. I may want to also understand what is the price per square foot. So maybe if I could calculate the price, so let's say we'll do another one. This is going to be a decimal since it's price. We'll say calculate price given, let's call this a decimal, cost per square foot. Let's say cost per cubic. Actually, let's make it a little more interesting. We'll make this cost per cubic inch. So whatever the cost per cubic inch is, they're going to provide that to us. What we need to do is we need to take the base width, the length, width, and height, and convert that into cubic inches, where we're going to assume this is in cubic feet. So what I'll do is I'll say var cubic feet equals this dot calculate area. We've already got that, so I don't need to redo that. Var cubic inches equals cubic feet times 12 times 12 times 12. Right? So we're just going to take each side and multiply it by 12 to get our total cubic inches. Not cubit, cubic. And then from there, we simply return cubic inches times cost per cubic inch. And now we have our total that calculates our price. And again, we could have other things. Let's say we want to change the color. Let's say void set color. Color, I'm going to do color instead of value. You could certainly do value. We'll say this color equals the new color. And so on and so forth. So again, I can add more methods as I need to, as that's going to be used inside the application. Maybe they can change their mind and change the width. Maybe they can change their mind and change the height. So once I create a shed, not actually physical, maybe this is a shed plan. Once I create a shed, maybe I can go back and change the definition before we physically send that off to the fabric or to the manufacturing plant to actually create this. So there's another example. Let's do one more example just to kind of reinforce everything. We'll do public class, and again, we'll do a different scenario. I'm going to create an inventory item class. So in this particular case, we're going to create a program that is keeping track of inventory for a business. Maybe it's a toy business, or it's a goods business. Maybe it's a Walmart or a Kroger, who knows what it is. So we're going to have inventory items. So once again, we're going to have fields, constructors, and methods. And we need to understand what are the data points that we're going to store with each of these inventory items. So what does an inventory item have? Well, it's going to have an ISBN code. So we're going to create a code, and we'll just do that as a string for now. So that's the identifying code. That is the code that lets us know this is the item in the system. That's what's going to be used on the barcodes. That's what's going to be used to pull up the price and everything else. We're also going to need a price per unit. We're going to need a name of it. That might be nice. And maybe we even want a description. So we can have that in the system so we can understand the difference between broccoli and broccolini, for example. So sometimes you don't want just a name. Maybe you want to be able to have a description so you can have more details. We could also have other fields on here. Maybe there's discounts we could add. Maybe there's color that we could add so we have some more information about this particular inventory item. Maybe we have an aisle number, so we could have the aisle number as a part of the inventory item. So lots of different fields. I'm going to keep it simple for now, but use your imagination, right? Each inventory item may have a lot of different data fields that we may want to keep for it. So now we need to figure out, how do we construct one of these things? Well, in an inventory item, we're certainly going to need most of these data points. And let's say we always need those data points, except for description. That's the one that's optional. So we'll say, here's our constructor, and we're going to need a string. The code is absolutely required. That's how we uniquely identify it. So that'll be first. Then we're also going to want a name. That's going to be important. And then decimal price. And those are kind of the big three that we're going to need. So we'll simply hold on to those. There's our constructor. And I'm only going to create one in this particular case. We talked with everybody and they said description isn't needed. We could add it later if we want to, so it's optional. But we can add it later. So let's go and add the ability to do that. We'll say set description string. I'll do value again. I could call it description, and we'll simply say this description equals value. So now we have the ability to set the description. We also may need to do a price adjustment. So we're going to need to be able to set the price. I'll do value again. So now we have the ability to change the price. Maybe we can even change the name. I'm not going to do that here, but you can imagine. What are some other methods we might need to be able to do? Maybe we need to calculate a subtotal for this amount. So we want to say, given a quantity, calculate total amount. So we'll say void, this will be decimal, calculate subtotal, and we'll say int 32, this will be quantity. So if I have 1, it's 1. If I have 3, it's 3. We'll simply return price times the quantity. And now we have a nice helper method to say, here's how many items there are. Calculate the subtotal for this particular line item so we have that available to us. And so on and so forth. Maybe I could calculate the tax on this. Maybe there's something that says whether or not it's taxable. All right, so produce might not be taxable, but something prepared, something microwaved might be taxable. So all sorts of different methods that I could create here, other fields that I could create. But when I create an inventory item, it's going to have all of this behavior. So if I have, for example, broccoli, it's going to be a new inventory item, and we're going to give it some code. I just made that up. The name will be broccoli, and the price will be, we're going to do this fairly cheap. We'll say 99 cents per head. So now we have the broccoli item. Now that we have that broccoli item, I can say calculate subtotal, given they put 3 heads in there. So now there's subtotal line item, and now I can display the subtotal to the user. And then I could create another item that's a different type of inventory item. Maybe it's a toy, maybe it's a bucket of paint, whatever it is. So again, I have different inventory items, and now each one has all of these different fields. They have all of the different constructors, different optional ways to create them, and all of the different methods. So that's basically the long and short of classes. Hopefully that makes sense. To kind of review, Classes are, think of them as blueprints, they're templates, they're the definition for what's common across all of the different elements of this thing. So every inventory item has these different fields. Every inventory item gives us methods that let us interact with it through the different methods, and every inventory item has specific ways that we're allowed to construct it. Inventory items only have one constructor, sheds have two constructors, and employees also have two constructors, two options. So that's the idea. Hopefully that helps demystify what classes are. We use them all the time. Please let me know if you have any questions. Keep bringing awesome to the people.